Welcome to another video, and right now I'm going to talk to you about differences of squares. Okay, so we all know what squares are, right? Perfect squares are something like, 4, 9, 25, x squared, right? Y to the fourth, maybe 16x squared. So these are perfect squares because we can square root all these numbers, and we're not going to be kind of having to deal with the hassle of writing out all these decimals because the square root of 4 is 2, square root of 9 is 3, square root of 25 is 5, square root of x squared is x, square root of y to the fourth is y squared, right? That's those exponent laws. Square root of 16x squared is 4x. So these are perfect squares because we can square root them and we're going to get whole numbers or, whole variables. So differences of squares is only dealing with perfect squares. You can only use this factoring method if you have um, two perfect squares that are subtracting from each other. So, for example, a difference of squares would be 9x squared, right, minus 4. Okay, so how could we go about factoring this? Well, we can't really think of like the traditional method of two numbers that multiply to -4 and, well, there's nothing really here, so like add to 0, and that wouldn't even work because we have a 9 in front. So differences of squares, this factoring method is a super kind of handy way um, to factor expressions quickly if we're only dealing with perfect squares and they're being subtracted from each other. Okay, so kind of the process is we take the square root of the first number. Okay, so the square root of the first term, 9x squared, that's 3x. That's going to start both brackets, okay? They're both going to be 3x. And then we take the square root of the second number, right? So the square root of 4 is 2. Take the square root of 2. And then all we do after that is we add a plus here and a minus here. So that's kind of a method to the madness. And if you expand this out, we'll get 3x times 3x, that's 9x squared, right? We'll get 3x times -2, which is -6x. We'll get this 2 times 3x, which is plus 6x. And we'll get this 2 times -2, which is -4. So see how when you take differences of squares and you factor it, the way we just did, these middle terms cancel. And you're going to get what we originally had, 9x squared minus 4. So these two brackets are exactly the same. The only difference is that one is adding the second term and one is subtracting it. Okay, so let's do another example here. How about we had one with fractions, everyone's favorite. So let's do 16 over 25 x to the fourth minus, let's go minus 4. Let's go minus 4y squared. Okay, so this is a little more ugly, right? There's not a lot of nice whole numbers to start, but these are in fact a set of differences of squares. 16 over 25 is a perfect square, even though it's a fraction. X to the fourth is x squared squared, right? X squared raised to the second power, so that's a square. 4 is a square, it's the square of 2, and y squared is the square of y. So there's no reason we can't use differences of squares to factor this expression because it is being subtracted, right? This 4y squared is being subtracted from the first term, so that's a difference, and they're both squares, so it's a difference of squares. And it's the exact same process as the question we just did, so we add a plus here and a minus here. Okay, we take the square root of the first term. Okay, so what's the square root of 16 over 25? Okay, so the square root, I'll do it over here, of 16 over 25 is equal to the square root of 16 divided by the square root of 25. So that square root kind of applies into both numbers. Square root of 16 is 4, square root of 25 is 5. Okay, so see how that is a perfect square? 16 over 25 is 4 over 5 squared. Okay, so that's 4 over 5. And we still have this x to the fourth here kind of attached. So the square root of x to the fourth is going to be x squared, because if we take x squared, right, and we raise it to the second power, remember these powers multiply, so that's going to be x to the power of 4. So the variable that's attached to the 4 over 5 is going to be x squared. Okay, and this 4/5 x squared is going to start both brackets. It's going to lead our set of terms. And then remember, we add the square root of the second number in the first term, and we subtract the square root of the second number in the second bracket here. So the square root of 4y squared, that's going to be 2y, because the square root, like I said, of 4 is 2, and the square root of y squared is y. We're going to subtract 2y. Okay, so now we are done the question, and that is essentially all you need to know about differences of squares. So as long as you know that, as long as you can identify what a difference of squares is, right? We have two squares here, and it's a difference, right? We're subtracting them. We know we can make two brackets. They're going to be exactly the same. The left is going to be the same as the right. Only difference is that there's a plus in one of them and a minus in the other. There's a plus in one and a minus in the other because when we do that, these middle terms after we expand are going to cancel, and we're going to be left with what we originally started with, right? So that's kind of how you go about doing that. I hope this helped, and I'll see you in my next video.